Hey, we're going to start with the briefest imaginable review of the basics of integration. Let's jump right into it. Here we have a list of some of the basic rules of integration. The first few are a little bit more theoretical. First one says that you can pull a constant outside of an integral. The second and third, the integral of a sum is the sum of the integrals. The integral of the difference is the difference of the integrals. And then they get more specific. How do you integrate x to the n? Well, the integral of x to the n is 1 over n plus 1 times x to the n plus 1 plus a constant because there are infinitely many functions that satisfy that antiderivative. Integral of 1 over x, the natural log of the absolute value of x plus a constant, etc. Why is the integral of e to the x dx e to the x plus a constant? Because the derivative of e to the x plus a constant is e to the x. Might have been better. Let's jump ahead. Let's look at number 9. You know that the derivative of the tangent of x is the secant squared of x. And so that means that the integral of the secant squared of x is the tangent of x plus a constant because there are infinitely many antiderivatives of the secant squared. And so these are all review. Go through them carefully. Make sure you remember them. We'll practice a couple in a second, and then there'll be a homework assignment that gives you some more practice so that you're up to speed with where you should be from your last class where you studied the very basics of integration, and we can all be on the same page. I'll briefly mention the last two. It's important to understand that the derivative of the arctangent, the inverse tangent of x, is 1 over 1 plus x squared. So the integral of 1 over 1 plus x squared with respect to x is the arctangent of x plus a constant. That one shows up all the time. And the one below it for the arcsine shows up a little less often. We'll need it in a week or two when we look at integration by trigonometric substitution. If you recognize and have that one memorized, it might save you some trouble every now and then. Not quite as important as the ones that came before it. Okay, let's try a couple of examples. Take a minute and see if you can compute this integral, the integral of 4 over x minus the secant squared of x plus 6 over x squared plus 1 with respect to x. Pause the video. When you're ready, start it back up again. And you should have gotten that it's 4 times the natural log of the absolute value of x minus the tangent of x plus 6 times the arctangent of x plus a constant. Forget the absolute values on the natural log. Some homework problems will accept that and some will not. Try to remember the absolute values on the natural log there. You forget the plus c at the end. Some homework problems will be okay with that, some will not. I will generally not be okay with that. You will usually lose some sort of points for that. The beautiful thing about these antiderivatives, these indefinite integrals, they're really easy to check. Take the derivative of the function that you came up with here, and you better get 4 over x minus secant squared x plus 6 over x squared plus 1. And just a quick note, if you'd prefer to write the inverse tangent as tangent to the -1 instead of arctangent, they're the same thing. I don't care how you write it, you choose. We should practice one definite integral before I set you loose on your homework. You should recall that the integral from a to b of f of x dx is equal to capital F of b minus capital F of a, where capital F of x is any antiderivative of the function lowercase f of x. So take another minute or two, try this problem. Pause the video, work this out. When you're good and ready, start it up again, and we'll go through the answer. Taking the antiderivative, you get x plus 1/2 x squared plus e to the x. Check, take the derivative of x plus 1/2 x squared plus e to the x, and you'll get 1 plus x plus e to the x. And since this is a definite integral, we now have to evaluate that from 0 to 1, which simply means plugging 1 into the expression and then subtracting what you get when you plug 0 into the expression. You have to be careful. You have to subtract the entire expression evaluated at 0, so we really need those parentheses in that second term there. And you also have to be careful because e to the 0 is not 0, it's 1. And so you do out the arithmetic and you end up with 1/2 plus e as the answer. Okay, as promised, that was a blazingly fast review of integration. Go do the homework and make sure that you're up to speed on that stuff so that you're ready to start our first technique of integration, which will be substitution, which we'll be starting very soon. All right, see you in class. Bye.